Well, now we get the opportunity to look at angles of elevation and angles of depression. And we can use trigonometric functions and their inverses to determine real life situations, either to determine distances or angles. So let's see, well, what is an angle of elevation? Well, an angle of elevation is formed by the horizontal line and an observer's line of sight to an object above that horizontal line. An angle of depression is an angle formed by a horizontal line and the observer's line of sight below the horizontal line. So angle of elevation is the line of sight from a horizontal line above the horizontal line. And an angle of depression is the line of sight from a horizontal line below that horizontal line. Now, horizontal lines are parallel, so the angle of elevation and the angle of depression are congruent by the alternate interior angle theorem. And we'll be able to see that here in a couple of examples of what we're getting ready to do. So let's first look at an angle of elevation. So here we got an interesting little problem, which says the crossbar of a goalpost is 10 feet high. If a field goal attempt is made from 25 yards from the base of the goalpost that clears the goal by 1 foot, what is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? Now we're dealing with trigonometric functions. And as I have been saying, one thing I may want to do is write SOHCAHTOA at the top of my page. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And another thing I want to do is I want to think about sketching whatever it is I'm looking at. It doesn't have to be a perfect sketch, just got to be something that helps your mind focus on what we're trying to do. Now, in this case, we're told that the crossbar of a goalpost is 10 feet high. So from this goalpost right here down to the ground is 10 feet. And the guy's going to make a field goal attempt 25 yards from the base. Let me see if I can draw anything close to a straight line. Well, not really close, but whatever. So we're down on the ground. This is 25 yards away. So this is 10 feet. 10 feet. This is 25 yards. All right, and the ball clears the goal by 1 foot. So the ball is going up 1 foot. It's going to clear, let's say, right about there, the top of that line. What is the smallest angle of elevation at which the ball could have been kicked? And so what we're trying to determine is, what is this angle that would be formed from where the guy kicked? What angle would the kick have to leave the ground in order to clear that goalpost by 1 foot? All right, well, you might notice right here, from the goalpost, the clearing of the goalpost down to the ground, that forms a right angle. And we got a horizontal line down on the ground. Our line of sight is from where the kicker is going to kick the ball and to where it clears the goal. So we're looking for this angle right here. What is that angle? Now, in order to orient myself with my sides, I want to find my hypotenuse, and my hypotenuse is directly across from the right angle. So if I'm trying to find this angle here, x, and I know that I've got one line that we've drawn that is 11 feet, so this is now 11 feet because it's clearing the goalpost by 1 foot. And I got a line running along the ground that's 25 yards. Well, I've got opposite over adjacent from this angle. The height where the ball is going to clear the goal is opposite, and the horizontal line running from the field where the kicker is going to kick to the goalpost is 25 yards. And so I can see opposite over adjacent, opposite over adjacent. Well, I'm going to use some kind of tangent function. But before I get too excited, I got to think about units of measurement. The goalpost is 10 feet high. It clears the goal by 1 foot. But the field goal attempt is 25 yards away. So even though I'm going to use the inverse tangent function to find that angle, because I got opposite over adjacent, and I'm trying to find an angle, so I'm going to use the inverse tangent function, I got to get my units of measurement the same. So let's see, I got 11 feet and I got 25 yards. Well, perhaps I want to get everything in terms of feet. So here's my question. How many feet is 25 yards? Or how many yards is in a foot? Well, if I'm doing conversion, unit conversion, let's say I got 25 yards. And I'm going to put my conversion ratio up here. Let's call that just 25 over 1. And then when I do my conversion ratio, I want my conversion ratio to be what I'm converting to over what I'm converting from. Now, how many feet are in a yard? Well, there's 3 feet in 1 yard. All right, 1 yard. Now, if I multiply these two together, guess what? My yards are going to cancel. And then I've got 25 times 3, and so there's 75 feet in a yard. So I'm going to convert this 25 yards into 75 feet. I got 11 feet height that my kick's got to go. It's going to be from 75 feet away. And so I can then just simply set my equation up that the inverse tangent of x equals 11 feet over 75 feet. And that's going to give me an angle. So the angle of elevation, or the angle of x, is going to be, let's see, inverse tangent, 11 over 75, enter 8.3. It's going to be approximately 8 feet. So our kicker is going to have to make this kick with an angle of elevation of 8 feet from 25 yards or 75 feet away in order to clear the goalpost by 1 foot, or actually reach a total height of 11 feet. And that, my friends and neighbors and countrymen, is how we can use an angle of elevation.